Hello, everyone, and welcome from my home office here in Southern California. Thank you for joining us on this Teledyne and MARTAC webinar to feature the latest in unmanned surface vehicles and hydrographic surveying. It's our afternoon session. We have one session this morning. It went quite well, so we're looking forward to getting this one going here in a few seconds. I certainly appreciate everyone taking the opportunity to join us to demonstrate the possibilities of this technology for remote operations, especially in situations like the one we find ourselves in today during this ongoing pandemic. My name is Jeff Dean. I'm the USA Sales Manager for Teledyne KARRIS, and I'll be your host for this session. I'll be joined today by a number of people involved in putting this event together who you'll be hearing from shortly. We have Tom Hansen, who is the Chief Operating Officer for Marine Tactical Systems, MARTAC, in Florida. Rob O'Malley, who's the Technical Business Development Officer for Teledyne Marine. Also joining us, Rich Inda, Field Service Engineer for Teledyne Marine. And from Teledyne Optech, we have Gaspar Lima, Product Manager for Terrestrial Products. He's here to speak about our Optek Lidar solution. He's joining us from Ontario. Out in the field in Florida, we are joined by Sean Murphy, Business Unit Manager for Subsurface Operations for MARTAC, and Jeff Cruz, Field Service Engineer for Teledyne Marine. And of course, myself, as I mentioned earlier, the USA Sales Manager for Teledyne KARRIS. In addition to hosting, I'll be talking specifically about Teledyne KARRIS's onboard near real-time post-processing system. Just to quickly go over the format of this webinar. For the first part, we have prepared a few slides to provide an overview of the system being demonstrated. Following that, we'll have a live session showing the system in operation, conducting a survey in Black Creek, and then, time permitting, we will conclude by answering any questions. So there is a Q&A section on the GoToMeeting interface where you can submit any questions you might have as we present. And we'll certainly try to answer as many questions as we can in the allotted time, but if we cannot get to them, we'll be providing feedback on those questions in a follow-up after the session. The focus of this event will be in demonstrating that unmanned vehicles coupled with the right sensor payloads and automated real-time processing applications can be the right approach for nearshore surveys that provides an alternative to traditional manned hydrographic survey operations. For our operation today, you can see that we are in a confined waterway in South Florida with maximum water depth to about 25 feet. There are a few low bridges in the area like the one you'll see in the video that's playing on your screen, and some other hazards that are a good representation of where a complete autonomous solution that includes below and above water data collection is a more efficient and safe approach to these types of missions. The smaller unmanned system here can get data coverage where larger manned survey vessels cannot. The personnel required on site is lower, and they can focus on the survey and data collection from a safe location nearby without having the other factors that come with larger manned vessels. This is just one of the scenarios, of course. There are many applications where this technology can be applied. I'll come back to that in a second, but for now, I'll go through and show you our setup for today. So the configuration we have for this particular demonstration includes three main hardware components, including the Mantis T12 unmanned vessel, fitted with a RESON SeaBat T20 Multibeam for subsurface data collection, and the Optek Lidar CL360M for surface scanning. On the software side, we have the Mantis command and control software for vessel control, the Teledyne PDS acquisition software for data collection from the sonar and lidar, and KARRIS Onboard providing the automated data processing and near real-time data stream for all these components. This is a system we have on station in Black Creek being operated by Sean, and that you will see in action during the live portion coming up here shortly. But one important thing to mention here is that everything you see here is contained in the T12 vessel you see at the top left. With the LiDAR mounted on the top, the T20 Sonar affixed to the hull, and all the command and control software, PDS and KARRIS on board installed in the Mantis computer bay shown on the bottom left. So as I said, coming back now to applications. So this type of complete autonomous solution is suited to a variety of scenarios and use cases. It applies to civilian applications in survey engineering for coastal zone management, ports, waterways, harbors, inlets, or even open ocean. It is really suited to any type of data collection in support of things like asset and infrastructure inspection, scientific research, or environmental assessments. And in defense and security is well suited to missions such as search and rescue, situational awareness, and threat detection. In this case, we've selected the vessel and payload based on the best fit for our mission and environment, but the mission will drive the configuration, which is flexible based on the length of vessel, the type of propulsion, the number and types of sensors to be deployed. And this type of solution is ideally suited to missions that require near real-time data and information made possible by the automated data processing and the output from that system. So now we'll go into a little bit more detail about the individual components. So I'm going to hand this over to Tom from MARTAC to talk about the T12 platform. Tom?
Thank you. Thanks everyone for joining today. It's glad to have you. So what you see in front of you is the Mantis T12, the 12-foot unmanned surface vessel. We produce these all the way from 8 feet up to 50 feet. We've done a lot of surveying with this. This particular vessel is a mature platform with 10 years of development and many military exercises. It was originally designed and developed for the military with that level of robustness. It's a very highly reliable platform and in fact very easy to use. An interesting note is it's fully floodable, which you don't have to do for this application, but that speaks to its robustness. In this application, it's been designed to be a very high quality scanning platform. This particular design, the catamaran hull, gives you very laminar flow. It's very low self noise, very low vibration, and hydrographers are continually surprised by the high quality we can get, where the sonar head is not even mounted that deeply in the water, allowing us to scan very shallow waterways that you just can't get to any other way, including going in close to dams. We did a job on a power plant with the RESON T20 in a Mississippi River where you couldn't go there with manned vessels. And another thing you'll see more of, you're going to see a lot of real-time data feeds today. There's a very sophisticated system of communications, of a 4-layer communication system for reliability and high bandwidth, and you'll see that today. And then finally, these vessels have a built-in swarming multi-boat capability, so that if you have an application where, for example, after a hurricane and you need to scan a harbor, you can actually cover a lot of area with multiple vessels. So that's kind of a quick summary, and I'll turn it back.
Thank you, Tom. Just a quick reminder before I move on to the next section, please use the Q&A section to submit any questions you have, and we'll try to answer them at the end of the webinar. So now I'll move over and pass it off to Rob to go over the RESON T20 sonar. Rob?
Thanks, Jeff. So the T20 sonar is a very high-end multi-beam echo sounder system. We offer our T20 as well as the bigger brother T50 system in a number of variants. We have a P, T20P for portable, R for rack mount, S for subsea. And in this particular configuration here in the upper right corner, you can see the sonar mounted to the bottom of the MARTAC vehicle here, which I might add is just phenomenal platform. And with the optional INS-20 mounted so that everything is geospatially referenced with the sonar data collection. So we have a number of different flexible deployment configurations. You can do dual heads here to cover more of the swath. We're running with a single unit here, light and flexible, only about 8 pounds in water. And you'll see just some amazing imagery a little bit later in a few minutes here. One of the things that gets us there is very high beam density. We're up to 1,024 beams out of the system. It's a 20-centimeter array. And we have a number of software features that really differentiate us with normalized backscatter, really providing the ability to harness our bottom algorithms and lock in, and some auto tuning features that enable hydrographic survey from an autonomous vessel, where remote operators can monitor, control, and perform quality control and assessment from an off-standing location, and the platform will continue to do the tuning in the short term and collect the high quality imagery. A little bit more on that in the processing side. Back to you, Jeff.
All right, thanks, So now we're going to head over to Gaspar to talk about the CL360M LiDAR. Go ahead, Gaspar.
Thanks, Jeff, and hello, everyone. So I want to introduce you guys the CL360M. It is a 3D laser scanner designed to collect everything above the water level and contribute to extend the survey capabilities to combine the sea and the land for a complete data set. So the CL360M is a marine-grade version of the CL360 sensor. It's another compact LiDAR from our family at Optek, and it is robust and solid for marine applications. This sensor is rated as IP67 marine-grade and designed for salt environment. It also it's a survey-grade accuracy system for high requirement engineering projects, right? So we're talking about a system that is capable of 10 millimeters range accuracy, and that for sure can expand your range of applications with confidence in results. This sensor is also carries a very powerful laser engine, so it shoots up to 500,000 points per second and 250 lines per second for fast scanning. That's 500,000 points per second being shot in the structure or the seashore. It's a super fast laser scanning for saving time in the field operations. It also carries a narrow beam divergence for small feature discrimination, like cables, wires, for clearance measurements, for instance, and any small details in the structures, including monitoring applications. In terms of range, it has a great coverage, so it can go up to 775 meters for incredible productivity. So even when you are scanning from far away in areas where the water is too shallow, you can still scan the object, structure, or buildings, ports, harbors, right? It's capable to provide up to 4 returns for complex environments or vegetation penetration. So it's a very powerful laser scanner from Optek that we are now bringing it to the marine sector. That's all I have, Jeff, for now.
Thanks, Gaspar. So now let's switch gears. We'll move off of hardware and to the software side. And to start that, I'm going to go back to Rob to give an overview of the acquisition software for PDS.
Yeah, thanks. Teledyne PDS, PDS originally standing for Positioning, Dredge, and Survey, is our data collection software. It's an application-based program designed to control, monitor, and record operations in real time. Although the original naming suggests, dredging and survey, this can really be leveraged for a wide number of applications, including port and harbor survey, security, construction, and in the case today, straight multi-beam survey. What's unique here is we've got one acquisition software for all sensor data gathering. So it's agnostic and it's geo-referencing and overlaying all of those data layers from all the different sensors and providing a real-time visualization to the operator. The displays are also customizable to show sonar wedge view, real-time displays of 3D data. So in this case, we've got LiDAR above and the multi-beam bathymetry below. So we're going multi-domain. And sensor data that you'll see through some of the interface display coming up here in a few minutes. The ability to leverage this interface to toggle settings. And I would say, one of the other great benefits we have here is also having Teledyne KARRIS as another company within the Teledyne portfolio. There is a really seamless workflow from PDS to KARRIS for the post-processing. And so what you're going to witness is near real-time data acquisition, collection, processing, and post-processed results in the user's hands in almost near real time, as Jeff is about to tell you.
All right, thanks, Rob. Great segue. So I'll move on now to Onboard. So as you just seen, we have an unmanned vessel set up to collect data from multiple sensors. KARRIS Onboard is the automation tool installed on a vessel that takes the sensor data and runs it through automation and routines to push out products to the remote observer or processor. By automating data processing on the platform and using a web application to remotely monitor those results, we can improve data QC, we can reduce deployment times, and minimize any processing backlog. During the initial setup of the system, the surveyor uses a process designer to customize an automated workflow specific to the sensor configuration and desired product output. You can pre-configure things like what type of data is being imported. And in this case, obviously, we're importing from the PDS raw collected data. We can apply tides, sound velocity corrections, on through to what type of products are going to support your decision-making and ongoing quality control checks. So that predefined workflow is going to provide a consistent, repeatable result across multiple platforms, sensors, and configurations. So you'll realize efficiencies gained in the workflow setup, but you're also going to be able to reduce risk and cost by remotely monitoring the survey results and being able to identify problems and correct them during the survey. KARRIS Onboard can be considered your single point of access to monitor your unmanned vessel or vessels in the case of having more than one system in operation. For example, if you have multiple unmanned systems working in tandem, Onboard can be installed on each one and the data reviewed together in one map view. So the best way to look at it, I think if you take a scenario that is typical of a traditional survey setup where you might have an online surveyor running the acquisition systems and then handing off the collected data to a data processor, he then begins the task of importing, correcting, and analyzing the data. In some cases, consider that that processor might also be on board a mothership waiting for the survey launch to return after a day of survey. Now imagine where you can introduce Onboard and automate that process up to a pre-processed final product that can be viewed from the remote vessel near real time. And I think you can easily see the benefits. So now we're going to switch over to the live demo going on in Florida. And I'm going to switch over now to my live view. And this is the system in operation in Black Creek. So to start things off, I'm going to hand things over to Tom again to talk about the command and control system you see on screen. Tom?
Hey, thank you, Jeff. This is Tom Hansen again from MARTAC. So what you're looking at is the task or command and control interface. If you look in the upper left quadrant, the very large map, that's the mission map. Right now, it's got imagery. It also supports charts, NOAA charts, Admiralty charts. If you look at that triangle that says USV on it, that's actually the MARTAC, the Mantis, our vessel, in real time, the T12. And the star with the red star and the white circle is the waypoint. Right now, Sean is driving it in manual mode. It's a manual operation. We have the ability to control the vessel in manual where you're just driving it, when you have rudder control and prop control. We also have what's called semi-autonomous mode where you basically set a waypoint and the vessel will go there. Sean just set a waypoint, so now it's in semi-autonomous mode, and off the vessel goes. It'll track right to that line. And then finally, we have a full autonomous mode in which you can pre-program missions. We support patterns. So for example, the classic zipper pattern of mowing the yard, the Mantis will go back and forth, and at the beginning of every path line, it will align itself and it will track accurately. We have proprietary software that's highly accurate and generally will stay within a meter and often a foot or two of the path line, depending on, of course, the day and the current level and all of that. That's the basic overview. Right now, Sean has got it in semi-autonomous mode. He's doing a survey. And finally, if you look at there's data in the middle near the bottom, and that will tell you specifics about what's going on with your vessel and with the survey, and integrates with the Teledyne software. And with that, I will hand it back.
All right, thanks, Tom. So we're going to switch over now to the acquisition side, acquisition and processing. And I'm going to also pass this off now to Rich Inna to walk us through the Sonar user interface and the PDS acquisition. Rich?
Thanks, Jeff. So I want to give a brief overview of the Sonar UI. The Sonar UI is designed to control the sonar itself. As you can see, we're looking at a history mode of the actual bottom detection as we're going. you can see the fine detail of the seafloor or the river floor. One of the key benefits to this application that we got going on here is the tracker mode. Tracker mode is basically like an autopilot mode that it uses the bottom detect algorithms to properly adjust all your settings so that the sonar basically runs itself. It'll set all its range, its transmit power, its gain, everything for you. So basically you can just reduce this display and let the sonar run by itself. Switch over to PDS. So PDS is our acquisition software. As you can see, we've already started a survey. You'll see two views. The one to the left is a 3D viewer. You'll basically see the scanner image as well as the bathymetry image, collecting both at the same time. You can pan and tilt, rotate, zoom into that so you can get fine detail of the imagery. If you look to the right bottom, that's the 2D view. That's basically set up so you can do your planned survey. You'll be able to put background layers like charts or run lines. There's a lot more different views as well that you can use. So we're just using these two for now. The viewer above that one is basically the raw data coming from each individual sensors. We can keep track of all sensors and make sure they're all functioning properly. Okay, Jeff, pass it back to you.
Okay, I'm now going to ask them to switch over to our onboard. There you go, coming up on screen. So thanks again, Rich. So we've just seen PDS collecting the raw data, and KARRIS Onboard is taking that raw data and using the predefined workflow I talked about earlier. It's creating the processed multibeam and LiDAR data that is properly georeferenced point cloud and corrected for sound velocity and vertical referencing. So one of the things you can do on this is you can apply real-time filtering, which can be used to apply such things as high pass or low pass filters on your sonar data, or specific depth ranges if it's required by the survey. And the control center for onboard, if you'll notice, it looks like a web browser. It's because it is. It is essentially a web page that allows the processed products to be streamed to a remote operator, allowing that remote real-time quality control from the unmanned survey vessel. It is essentially the website that gets streamed off the vessel that allows multiple people to log in and see this data in real time without interfering with the survey operations. In the same manner where we have the participants of this webinar viewing our survey in real time, the onboard stream can be provided to anyone with a browser that needs to have access and view the progress and results of the ongoing survey. So one thing we can do, we take this one step further, and in a second here, we should be switching over. We have the ability, here you go. So we have the ability to also view this real-time stream in our desktop application. What you're seeing right here now is what's different from what we just seen previously through the web browser interface, which is serving up essentially a reproduced image of the data. This is actually looking at the process georeference point cloud in our desktop application. And that allows us to do further quality control and analysis on the data. In this case, you're actually opening up the process data coming straight from the onboard project files. So you have same time real visibility as a web interface, but with more powerful tools available in the desktop KARRIS application. So as you can see here, you've got some really good detail on the bridge pilings, both above and below the water from both the LiDAR and the sonar at the same time. So this basically allows you to perform more advanced analysis on the integrated sonar and LiDAR data. And these are just two different flavors or options that you have with KARRIS Onboard based on your scenario, your bandwidth. You can stream this information to multiple users worldwide like we're doing here today. So in a sense, what Onboard is doing is is giving you a complete and processed data set that you can potentially deliver to your client straight off the vessel. Just imagine I'm the project manager or party chief sitting here in my living room in Southern California. I've just reviewed the survey completed in South Florida. It looks good to me, so I'm going to sign off on it. I'm going to send it to the client, and now I'm going to head off to the beach where all I have to worry about is social distancing guidelines, of course. So with that, I'm going to now switch back to our presentation. And we're going to review some of the benefits of the system we just saw. And apart from my sunset beach excursion that I'll take here shortly, what are the benefits of this solution? We have a flexible platform that can be integrated with a variety of components that can provide both above and below the water data collection. It can effectively minimize your operational costs, considering that you have a smaller and more efficient vessel, less personnel required to run missions, real-time verification of the data coverage and quality of the data being collected, meaning you can avoid the need to revisit the site because of missed coverage or quality issues. And you also now have an easily scalable solution with a range of platform and sensor options, whereby adding multiple vessels in swarm deployments, using similar setup parameters for automated collection and processing, you can quickly expand your coverage area with sensor data from all vessels available in a single application to monitor all the gathered data. So now that essentially covers the entire presentation at this point, and we've got the Q&A session open. I've got a number of questions come in. I'm going to start by taking a few of these questions randomly, and the first one is going to Tom specifically on the T12 vessel. Tom, the question to you is the vessel powered by lithium batteries, and how much time can you run a typical mission?
Yeah, good question. They are a lithium derivative. They're a new technology, so they're quite a bit safer and have better endurance characteristics than the lithium polymer batteries that you're probably familiar with. The typical mission, depending on the speed, current, whatever, is 6 to 12 hours. At a slow speed can go longer than that, but a good estimate is about 6 to 12 hours to plan on.
All right, thanks, Tom. Now I have a question on the LiDAR. This one will go over to Gaspar. Question is, you mentioned multiple LiDAR returns. Can you explain how that works?
Oh, thanks. Yeah, thanks for the question. Yeah, so basically the system is capable to record up to 4 returns for every single shot. So it is split in the first 2 returns and the last and the second last return. So maybe, on very complex environments such as, vegetation or foliage, when you have multiple different structures or even vegetation, so you may have N returns from the laser, right? But in a lot of applications, what we want is actually, the point that has more chance to reach the ground or to reach the wall behind the trees or behind this foliage, the mass of the foliage. So that's why the CL360 brings this capability, and the user can actually choose how to deal with those 4 returns.
All right, thanks, Gaspar. I got another question here going back to Tom on the vessel again. The question is, can you equip larger Mantis vessels with larger, more powerful sensors?
Yes, you can. These are the small. This is what we call the X class, the small series. It jumps up to 24, then 38, then 50-foot Mantis, which are easily able to take thousands of pounds of payload, and they have very high power generating capability. So the answer basically is yes.
Okay. Now we have a question coming in specifically about the sonar, so I'll pass it off to Rob. Rob, the question here is, what settings is Tracker automatically controlling?
Thanks for the question, Jeff. So Tracker, refers to some really smart features. Allows you, one of the main use cases that we're seeing a lot of interest in is our normalized backscatter feature license. And what that does is, as there's smarts built into the sonar head, and it's run on an autonomous platform, it will constantly retune itself to keep lock on the bottom and to provide the most clean data possible to speed up the acquisition and processing and results process. In doing that, normally with previous in previous sonars in survey, you would see a inconsistent environment as you tune the gain, or for example, you can change the pulse length of the signal. In this case, we make it available so that it normalizes all the backscatter, plus can also record the raw backscatter data. You can get both, and as far as I know, that's available nowhere else in the market right now.
All right, thanks, Rob. Now I have a question that's going to be to me on KARRIS Onboard. The question is, can you clarify if the data, each line or file, was being added to the surface DTM on the screen in the demo? Yes, actually, it's a good point that wasn't mentioned. The data that is being collected, the raw data, is being added in real time, and we're streaming that live. So the product surface, the DTM, is being updated in real time. And again, going back to bandwidth, we have a number of different options when we consider what that looks like. Streaming a lot of data over low bandwidth is quite possible with the system the way we designed it. So yes, you are getting real-time updates on your end product surface based on the raw data being collected. Okay, we have another question. This is a follow-on question going back to Tom regarding batteries and power. Question is, do the batteries power scale with a larger vessel?
Yeah, great question. The larger vessels today are diesel powered, and as an interesting adjunct to that, these boats are actually designed to go either semi-submersible or submersible. So in the next year or two, these the larger vessels are also going to have electric hybrid power. But right now, the larger vessels are diesel powered, and they have ranges in the order of hundreds and thousands of miles and days and weeks of ability to stay out on mission.
Okay, and we have another question here, and this one was asked this morning as well, so I'll bring it up again because it seems to be an interesting topic. This one goes to Gaspar regarding the LiDAR, and the question is on using this LiDAR in more than just this one environment. Can you use it on land or other types of vessels or vehicles?
Yeah. Okay, yeah, that's a good question. And people seems like to be interested in that, and that's absolutely true. So the CL family, the compact LiDAR family systems at Optek, they were designed to be versatile for different applications using different mounts or platforms. So yeah, the user can easily take it off from this vessel or from any sort of vessel and put it on a land vehicle platform, or even on a drone, right? So, or even in a backpack, right? And connect with the other systems, the IMU or any POS system, and collect the data in land or from a drone. Yeah, right now we have some partners around the globe using CL360, the regular version, on drones.
Okay, good. So the last question I think we'll take right here is going back to Onboard. The question is, how easy is it to transition your project from the field to your office and keep working on it? That's a very good question as well. Yes, that is very easy to do that. With KARRIS Onboard, all you need to do is copy it into an existing project and keep working. You might do this if you were needing to apply some kind of post-process navigation or SeaBat later. So while you do have a finished product coming off the onboard system on the vessel, you can take it one step further in the office with your KARRIS desktop software and continue on doing further analysis. But you also remember that the person in the office could be the one directly running Onboard remotely if the bandwidth supports the data transfer of the acquired data files. So all the exported data formats from the field, if they are intermediate or for QA or QC purposes, they're standard. So for example, GeoTIFF or ASCII. So yes, it is quite easy to transition from the field to the office if necessary with KARRIS Onboard. So that concludes our webinar for today. Just a quick recap. So on the screen, you have email addresses for some of the presenters here and specifically for points of contacts. We will be following up the webinar with follow on to answering any questions we did not cover from the session. And in particular, if you have questions that you want to reach directly out to any one of us here regarding Onboard, myself, Sean Murphy from MARTAC, Rob to cover Teledyne Marine and the PDS and the Sonar, and then Gaspar on the Optek side for the LiDAR, feel free to reach out to us. We'd be happy to get back to you. Again, I want to thank everybody for their time and taking the time to join us. I really enjoyed putting this off, as I'm sure all my other presenters did as well, and I want to thank them for their efforts in putting this together. Hope everyone is staying safe, and for that, I will end it, and have a good day, and I'll talk to you soon.